There we go. So now we are recording. All right. So let's get back to the homework assignment and get started with the budget homework assignment. All right. So reading the homework assignment, we kind of get a requirement of what the program is supposed to do. It first has to read a base 10 signed integer as the initial balance. Okay, so that's the first number you're supposed to read. And then you have to read consecutive base 10 signed integers as expenses. You have to stop reading, okay, when your program runs out of budget, which means your budget is less than or equal to 0. When we encounter end of file, or when you encounter an error when you're trying to read a number. And depending on the reason of why the program is stopping, you also have to return the appropriate code. And a few people asked me, okay, my program is only outputting 255 instead of a -1. Is that okay? And I think last time I illustrated that is what it will look like when you return a -1 from main. It will look like it is a 255 because of how signed numbers or how -1 is actually represented. All right. And there's not really a whole lot of additional restrictions other than you can not call any other subroutines other than the subroutines that you write or scanf itself, okay? But I don't really know of any particular subroutine that can get this done easily. So, that's not really that big of a deal. I think I have to readjust this one here by reducing the treble because it's too much high frequency. I think this is a little bit better. Yeah, sort of. Maybe. Okay. The best thing about this is I can walk anywhere and it will still be the same volume as far as the mic is concerned. So that part is nice. All right, so we'll go ahead and get started with this homework assignment. You're supposed to work on everything inside a subroutine called budget, and then the source code is supposed to be named main.cpp, and I will do exactly that too. So go to my home folder, make a new folder called budget, go to budget, and start my file called main.cpp. So as I said a little bit earlier, the first program that I'm writing is going to be iterative, which means it is only going to be a loop of some kind using conditional statements and whatnot. And then the other one, the next program, the second program, is going to be the recursive version. All right, so we know everything has to go into main. And now the question is, how do we get started with this code? Okay, I think last time I kind of gave myself an assignment, an in-class demonstration that is kind of what you have to do, but not quite exactly the same. So we know there's some kind of a loop, but we cannot do the loop until we have read the initial budget. So that means we have to have a variable for the budget itself. Okay, so we'll have a little budget variable. And then we also need some additional variables. Okay, so we'll need another variable. I call this scanf result. Okay, you can call it anything you want, but I would like to name my variables to clearly indicate the purpose of the variable. So the first thing I would do is to double check on my homework assignment description and see what I'm supposed to do. Okay. All right. So if the program exits because we run out of budget, return a 1 in main. If it exits because we encounter end of file, return a 0. If the program exits because there's an error reading a number, return -1. You can use any statement, any expression, any number of autolocal variables and define and invoke any function of your own, but you can only invoke scanf as a function that is applied to you. And I have a few examples here. All right, so it doesn't really make it very clear whether the first number can be problematic or not, okay? So I'm going to write the program as if the first number itself can be problematic. So what it will do is I am going to say scanf result equals to scanf, and then we specify %d because we are reading in a signed base 10 number, and we are reading it into budget. So we need an ampersand before budget because we need to supply an address of an integer, not an integer to scanf. And what I'll do is to say if scanf result is a 1, then we'll go ahead and do the rest in the then portion. Otherwise, we'll just go to the else portion. So what I'm doing right here is to basically say if the budget itself, the first number is not read correctly, we'll do something about it. And assuming the first number is read correctly, then we'll do something else. All right, so let me turn on auto indent because for programming, this is a lot more convenient. All right, so if I ever get to the else part, that means one of two things, okay? It means scan result is 0 or -1 because scan result can only be 0, 1, or -1 or scanf result because I only request to read only one thing. So if it returns 1, it means I read exactly one base 10 number. If it returns 0, it means there is something to read, but it's not a base 10 number. If it returns -1, it simply means, oh, the input file is empty. I have encountered end of file. Okay, so reading back my own description here, if the program exits because we run out of budget, return a 1. We don't know about that one yet, but we can, based on scanf result, we can determine whether we have encountered end of file, in which case we have to return a 0, or whether it has returned encountered a number, a non-number, then we have to return a -1. Okay, so we'll kind of do that later. Okay, so I'm just going to say, so sometimes I would do this to myself. Okay, I would write down something as to do and handle return value here. Okay, so I'm going to deal with this later, and there's a reason why I do it like this. If scan result is a 1, that means I did read a budget correctly. So assuming that I have read a budget, I can now enter a different loop because what I want to do is to keep reading expense items until one of the 3 conditions happen. Okay, but this can be a post-checking loop or a pre-checking loop. So I have a pre-checking loop here with a condition. Okay, so now the question is, what am I going to put into this condition on line 11? Okay, what are the conditions that will get me out of this loop here? What do you think? Okay, first of all, if you go back to the description of the homework assignment, what are the conditions where we can, exit the loop and go like, okay, we're done? First, we run out of budget. In other words, if the budget is less than or equal to 0, we get out. 2, we encounter end of file. We'll talk about how to determine whether we encountered end of file or not. And 3 is when there's an error reading any number. Okay. All right, let's handle the first one first, which is we are running out of budget. When we run out of budget, it means the budget or the balance is less than or equal to 0. So we already have the variable called budget. I can call it balance as well. But we can say the first reason to get out of the the first reason to get out is when the budget is less than or equal to 0. But if you flip it, what is the reason to stay in the loop? When it's greater than 0, right? So the first reason to stay in the loop is when the budget variable has a value that is greater than 0. Okay, but this alone by itself is not sufficient to stay in the loop because we also want to make sure that we are not encountering end of file and we are also not reading anything that is erroneous. Okay, so how can we tell whether we encountered those situations? Hey, we have this thing called scanf result. So what do we want scanf result to be in order to stay in the loop? It has to remain to be exactly 1 to stay in the loop. Okay, so now we have 2 conditions, and somehow, okay, I forgot to type the greater than 0 here. Okay, so there we go. So now we have 2 conditions. One condition is we have to have a positive budget. Okay, it has to be non-zero and positive. And 2 is we have to be scanning numbers correctly in order to stay in the loop. The question is, how do we merge or join these 2 expressions? What do you think? Do we want both of these to be true to stay in the loop, or do we want to have only one of these to be true to stay in the loop? Go ahead. We want both of them to be true to stay in the loop. If any one of these conditions becomes false, we want to get out of the loop.
We're talking about just I'm sorry, greater than, yeah, you're right.
Okay, so we want to, so knowing that we want both of these conditions to be true to stay in the loop, what condition or what operator should I put here? Yep, that's it, logical AND, okay? All right, so if I get here, okay, this is just my thing, okay? You may not do the same thing. Yep, go ahead.
Would it be better to use bitwise AND because it would evaluate faster potentially there?
Nope, you don't want to use bitwise AND, okay? Because bitwise AND is, because budget is greater than 0 as an expression, if it is true, it will only give you a non-zero value. You have no idea what is the actual value of this expression. And the other one is a comparison, and you have no idea what is the actual value. So if you use a bitwise AND, it may not work. Okay, in most cases it would. Okay, but it depends on how true is actually represented. So definitely not use a bitwise AND. Yep.
Does it matter if you just have it in one expression, like without having two sets of parentheses there?
I only use the extra parentheses for clarification, but in this case, if you do not have the inner parentheses, it will still work correctly, because comparison takes precedence over logical expressions. All right, so getting to this point here, I usually type, what does it mean if I'm here? So if I'm here, that means budget is greater than 0, and scanf result is exactly 1. All right, okay. So that means, okay, everything is still good. So the first thing I want to do is to do another scanf. And being lazy as I am, I'm going to copy and paste this one here, change the indentation. So now we are reading a second number, but we cannot call this budget anymore because I don't want to overwrite the variable called budget. So what I'll do is I'm going to declare a local variable as close to the context of using it as possible. So I will call this one potentially expense, okay? So this time I'm going to read into expense and not into budget anymore because I don't want to overwrite the budget. All right, so this is reading, attempting to read a number that is an expense. Just like with budget itself, three things can happen. Okay, I can either end up with an of file, I can end up with reading a number, reading something that is not a number, or attempt to read something that is not a number, or I can actually read a number itself. So now I have to differentiate all of those cases depending on scanf result. Okay, so we'll say, well, the only case I really have to do something is when scanf result is exactly 1. That is the only time I have to really do something because it means I actually read a number. If I did read a number, the first thing I do is to basically subtract that number from budget. So budget minus equal to expense. Okay, that's it. That's all I need to do because I just need to subtract the expense from the budget. On the other hand, what if budget or what if scanf result is not a 1? What if it's a 0? What if it's a -1? Well, it will still be caught by this condition, and then the loop will still exit. Okay, is that okay so far? Okay, if that is okay, then we'll go ahead and get to this part here. Okay, so once I get to the else part here, I'm not going to do a single thing in the else part. Instead, what I'll do is I'm going to check here and say if scanf, well, actually, I'll do it a little bit trickier. Okay, I can use one single return statement because I have the ternary operator. Okay, because the ternary operator would do about the same thing as a conditional statement, except it is in the form of an expression and not in the form of a statement. So in this case, I can now say, okay, let's do a return statement here. The first thing I want to do is to see whether scan result is a 1 or a 0 or a -1. Because if scanf result is a -1, that means I have encountered an of file. Does anyone remember what value I'm supposed to return when I encounter an of file?
0.
Okay, you're right. It is supposed to be a 0. Okay, so there's a 0 here. Otherwise, if I did not encounter an of file, I will have to look for the other two cases or the other two reasons to get out of this loop. The first one is when I detect something that is not a number. Okay, so when scanf result is a 0, it means there's something in the input file, but it is not a number. Okay, in that case, what am I supposed to return? If you just read the homework description, what am I supposed to return when I encounter something in the input file, but it is not a number? -1. And that means there's only one thing left. Because if I ever get to this point, okay, it can only be one of the 3 reasons, okay? So the only other reason is to, no, that is correct. So I have to return a 1 because I just ran out of budget. It has to be the last reason. Is that okay so far in terms of the logic of this code? Any questions about the program itself, about the logic of the code? No questions? All right. Well, if there are no questions, we can go ahead and compile the program and let it run. Yep, go ahead. Huh? Okay. So are you guys ready? Okay. So we'll go ahead and compile the program first. Okay. See if I have any syntax errors. No syntax errors. So we'll now go ahead and create the executable. Once we have the executable, we can run it. But remember what I said, if I want to test this program, I am going to test it with sample input files. So I'm going to create one sample file, at least one for each case, for each return value. So the first one is out of budget, okay, .txt. This will be my input file to test whether the logic to test out of budget is correct or not. So we'll start with $20. The first expense item is $10. The second one is $15. So I will have a -5 of budget left, and that's the reason why this program would exit. That's the first one. And we'll go ahead and edit a second file, which is eof.txt. Okay, for this one, we'll encounter end of file first. In fact, this is the first one that I'm going to use to test whether I see end of file first. So we start with a normal budget, which is $20, but that's it. Okay, no expense items. I encounter end of file as soon as I try to read an expense item. The next one is going to test whether I can handle lines that are not numbers. So we'll just call this non-number.txt. So we start off with $20. The first item is only $1. The second item is ABC, which is not even a number. All right, so now I have 3 test cases, and I need to test my program to see whether it works or not. Now, depending on my confidence in my coding skill, I may not even want to run the program by itself. I may want to run it inside GDB just so I can see how the program works and when it gets out of the loop. But if I'm confident about the code, I can just go ahead and run the program by itself, okay, outside of GDB. And I'll say out of budget.txt. It runs without crashing, but I need to know what is the return number, and the return code in this case is 1, which is correct. Then I'll test with a second test case, which is EOF. So with this one, it is supposed to return a 0. Okay, so I run the program. It did not crash, which is good. And I check the return value. It is a 0. Then I check out the last one, which is having a non-number in the input. Okay, it did not crash. That's good. Look at the return value. It is 255, and 255 is basically the reason why. The reason why it's reporting 255 is because we return a -1. So in this case, it worked on all of these 3 test cases, which does not really mean these are the only 3 test cases I can give you. It simply means it is representative of, I have 1 test case for each case, basically. Are there any questions about this particular solution, the non-recursive solution to this particular program? Any questions? No questions? All right. Well, if there are no questions, I'll give you the alternative to the iterative approach, which is the recursive approach. Okay. So let's see. I'm going to copy this to main 1, and then we'll go ahead and change main itself. Okay. So the recursive version still needs to read the budget itself separately, but once we have the budget, the rest will be done by a subroutine. Okay. And in this case, I will have an additional variable here called main return value. Main return value. And I will just say main return value equals to, well, for the lack of imagination, I'll just call the function f. And function f needs to do only one thing, which is, hey, what is the initial budget? Let me know what the budget is. Okay. And over here, I will change this code so that this part will just return main return value. Okay. The reason why I have to change this part is because scan result is completely local. It is only because of this initial scanf. If the initial scanf did read a particular number, which is meeting this case, then main return value is going to determine the actual return value, which is determined over here. So that's why, you know, it is now separated slightly. And then I can go back and write the subroutine f. Okay, the subroutine f is going to return an integer so that I can use that as main return value. It will only take one single parameter, which is also an integer, and that is the budget. Okay. All right. So this is recursive. What is the first thing you have to think about when you are writing a recursive function or a recursive subroutine? When do you stop, right? When do I stop the recursion? Okay. So based on just the budget itself, can you determine when to stop the recursion? Okay, so when do we stop? Just looking at budget, do we know when to stop? When budget is less than or equal to 0. Okay, so let's check for that first. Okay, so we'll say if budget is less than or equal to 0, then we'll basically stop. So I'll just say return value as my local variable. And over here, I'm going to simply say return value is known. It is going to be a, if I run out of budget, it is supposed to return a 1. So that's what it is. All right, so now what next? Well, let's deal with everything in the else portion here. Okay, so the else portion is basically saying the budget is greater than 0. Okay, so what can we do? We'll go ahead and try to read an expense item. That's what we're going to do. As we do that, we'll want to remember the scanf result. Okay, and we'll say scanf result is the return value of scanf. We are reading a integer signed into an expense item, and that is also a local variable called expense within this particular block here. And then we can now determine, okay, was this attempt to scanf successful? So we can say if scanf result is 1, which means it is successful, we'll do one thing. Else if scanf result is less than 0, which means we encounter end of file, we'll do something else. Else, which is reading something that is not a number, that's my last case. So there are 3 cases here that we need to handle. In the first case, when we did successfully read a number, the first thing we'll do is we'll subtract that from the budget, which is passed to this function as a parameter. So we'll say budget minus equal to expense. And you know what? I'm just going to blindly call the subroutine again. But whatever the subroutine is going to return, that becomes my return value. So I will say my return value is just the return value of calling the same subroutine again, but using the updated budget. So I'm not even going to bother to check whether budget is less than or equal to 0 at this point, because the next invocation can check it. Okay. Are we doing okay so far with this code here? So this is the recursive part, because I still have a, I may have a non-zero budget at this point, but I'm just going to call the subroutine again and let the next invocation to determine what is the actual return value. In this case, when the scan result is less than 0, it means I encountered end of file. If I encounter end of file, I know exactly what I'm supposed to return. I'm supposed to return a 0. Is that making any sense? Well, the first one is easier. You mean the iterative version? Well, the iterative version is usually easier for certain things, and then this one is usually more friendly for other things. Okay, this else case is when I'm reading anything that is not a number, so -1 is supposed to be the return value. So this is the recursive version of the very same logic that we went through in the previous program. Well, at least that's my claim. So how do we know this works or not? Well, we'll go ahead and test it, right? And then we'll run it, and we'll test it with the first test case. The first test case is out of budget. It is returning a 15, so that's not working. Yeah, that's not working. All right, so if it is not working, we'll have to find out why it's not working. I already know why it's not working. Let's go ahead and take a closer look at, just need to make sure I'm not, there we go. We'll take a quick look at F. Do you guys see a return statement in function F? No, there's no return statement. So if there's no return statement, what is the return value at the end of function F? Can be anything. Okay? And that's why we got a 15, because I did not specify the actual return value. So what we need to do is to make sure that we have a return statement here. But I actually made a mistake, and I have no one else to blame except for myself if this is the program that I'm turning in, because when we compile the program, what did I forget? Warn all. Okay, so we'll turn on warn all and see what the compiler has to say. Oh, the compiler says variable return value is set but not used. Okay, sometimes we get that. Okay, but what about the next warning message? No return statement in function returning a non-void type. That is a clear indication that we have an issue here. So that's why we have a problem, because I did not specify a return value when the return type of a function is not a void. Okay, if it's a void, you don't need a return statement. But if it is not a void, you have to specify the return value. So at the end of the entire function, I have to remember to say return value, which is the name of the variable that is supposed to store the return value. All right, so that's. Oh, sorry.
Result value.
Huh?
You put result value as the variable.
Result value.
You go down to the return statement.
I missed. Oh, okay. Thank you. There we go. All right. So what we'll do is we'll recompile the program. Oops. G++. And then we'll have to relink the program. And then we'll retry the first test case. There we go. And it does return a value of 1. We'll try the second test case, which is EOF. That returned a 0, which is correct. And we'll also try out the last test case, where we have a non-number. And that one is supposed to return a -1, which is reported as 255, and that is correct as well. Okay. So are there any questions at this point about the iterative version or the recursive version of this particular program? No particular questions? Okay. when you guys were working on this program, what was the main challenge? Or there was no challenge whatsoever. Getting all the pieces, okay? And so what did you do to get all the pieces together? Yeah. Yep. You have to spend the time to figure out how the pieces are supposed to connect. Okay, so because we have a lot of ways to combine the different pieces. So you have to find out how we can put all those pieces together. All right. So if this is all done, are there any additional questions before we move on to talk about pointers and addresses? Going once, going twice.
Can you go back to the source code for the recursive one just real fast?
Absolutely. There we go.
Okay.
I can turn on line numbers so we can refer to.
I was just trying to figure out if you had made it self with recursive or if you had a different function because you were coding so fast. Figured it out.
Oh,
Thank you.
okay. All right. All right. Any other questions? Okay. If there are no other questions, I just want to make sure the recorder is still going because sometimes it stops. And okay, recorder is still going. That's good. All right. Okay, next thing is we are moving on. We are skipping a little bit of file input output, and we are moving on to pointers because pointers is a very big topic. It is very important, and we can get back to some of the input output stuff later on. Okay, with pointers, which is actually about addresses first and then pointers next. We have one reading material, which is pointers, the first contact. That's just a reading slide. And then you also have a homework assignment. This is your homework assignment for this week. It is not a programming assignment. Instead, it is in the form of a quiz. Now, even though it's in the form of a quiz, there's no limitation of how much time you can spend to get it done. Okay? In other words, you can open the quiz and spend 6 days on it. Okay? So there's only a final due date, which is 1 o'clock next Monday. Okay, and as long as you can turn it in by next Monday at 1 o'clock, it's still okay. But there are steps within this quiz that you actually have to do using GCC and also GDB. So you have to allow yourself, enough time to do it. So I would say for those of you who have used GDB quite a bit and know how to get in and out of the compiler and write some code and stuff like that, it might take you, I don't know, it's hard to say, but I would say you might want to prepare at least an hour, for this particular quote-unquote homework assignment. But on top of just doing the lab stuff, there's also, a discussion of concepts and whatnot. So you might want to read the first chunk first, read pointers, the first contact first, and then, try to do the lab, okay? When you're doing the lab, you are allowed to go back and forth. Okay, except it won't tell you what is the right answer until the homework assignment is due. So you'll be in the dark for the most part, not knowing whether your answers are right or wrong. But you can still go back and change it, anytime within this week, as long as you have not submitted the quiz itself. Okay, so there's a bit of time for you guys to do it, but I would start early, okay, because you have to understand the concepts before you start to do it. Yep.
Wait, only one attempt.
It's only one attempt, yes. This is not one of those reading material where I just use the quiz form to make it more interactive. This one is actually a piece of assessment. Okay. All right, so what I'll do is I'm going to click on this piece here, okay? And some of you probably have read it because I told you guys, through email that I am going to move on to pointers and addresses. But instead of just reading this to you, which is going to be extremely boring, okay? I am going to use GDB to illustrate some of the concepts. So what I'll do is I'm going to write a program, which is not necessarily the program that you have to handle within the homework assignment itself. Okay, so we'll go ahead and make dir vars, okay? And this is the program. main, and we have three variables, x, y, and z. Okay, and we'll have x equals 2, y equals x plus 1. Okay, and then we have z equals to y times 2 plus y plus x. Okay, that's close enough. Return 0. Okay, the code is not even that important. Okay, because when we go through GDB in this case, we'll be looking at something other than what these values or what the values of x, y, and z are going to be. But it doesn't hurt to try to execute this program in our minds and find out what the values of x, y, and z are supposed to be by the time we get to the return statement. X is quite easy. X should have a value of 2. Y should have a value of 3. Now since x is 2 and y is 3, z should end up with a value of 8. Okay? So we kind of know what this program is supposed to do. It doesn't seem to have anything to do with pointers because I don't see any ampersand, to take the address of something. I don't see any asterisk to dereference a pointer either. Okay? But we are going to do everything in GDB. All right. So we'll go ahead and just, compile this program. Warn all is going to complain because x, y, and z. Well, not x, y, and z. Z itself is set but never used. So we know the compiler is going to complain about that, which is exactly what it's doing, right? It's saying, variable z is set but not used. But that's okay because that's, it's just a test program. And then we'll link the program so we can run it in GDB. Okay. In GDB, we'll set a breakpoint on line 5. Okay, we'll set the breakpoint on line 5. Run the program first. Okay, you have to run the program. We hit the breakpoint, and then at this point, the program is paused. Okay, it is actually executing. A program in execution is called a process. Okay, and you can only examine variables when you're dealing with a process, but not when you're dealing with a program. Are there any questions about what is the difference? What is the difference between a program versus a process? A program is nothing more than a set of instructions, okay, which is sitting in a file in your computer. A process, on the other hand, is a program in execution. It is a particular instance of a program running. In this case, because we are now stopping at a breakpoint, we're stopping in a process. And not very surprisingly, we can print x. X is not initialized yet. It just has a value of 0 to begin with. We can say what is y. Y has some gibberish because it is not initialized. And the same thing about z. It is not initialized, so it has some kind of gibberish value. Okay, nothing too surprising at this point. We can single step. Okay, once we single step line 5, nothing really exciting is happening in this program. X has now a value of 2. Y and z remain unchanged because the assignment statement does not affect the other two variables. So, what about pointers? What about addresses and stuff like that? Well, as it turns out, GDB understands the syntax of C++ fairly well. So that means I can use the ampersand, the unary operation of ampersand, because if you use it as a binary operator, it is bitwise AND. But when you use only one side, if you only specify a value on the right-hand side of ampersand, it becomes the address of operator. Okay? There's no particular short name for it. Most people just call it the address of operator. So when you do this, press the Enter key, it gives you something that goes like, what? That's not x. What is that number? Well, that's the address of a variable. Okay. Okay. So looking at this, quite a few things can be confusing at this point. Okay. The first one is what is int asterisk? Okay. What does that mean? And then the second one is what about this number? It's not even close to 2. Why do we have this kind of gibberish here? B, F, 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 F3, D, 4. Okay, so we'll go ahead and try to answer these questions, one by one. The first one is actually the number itself. Well, the first one is where are our variables? What do you think? Why do you think you need to have 16 gigs of RAM on your computer? when you run a program, what is taking up RAM, or random access memory? Variables, yep, variables and other things. Okay, there are many other things, but variables, for one thing, will use up memory. Okay, but what exactly is memory? When you go to Fry's and buy memory, how do you measure how much memory you're buying?
Generally gigabytes.
In gigabytes, okay, very good. So giga is really nothing more than a quantity, right? One gig is a billion. But the basic unit is bytes, okay? So you're still measuring memory capacity in bytes. What is that telling you? It means memory is byte addressable. Okay? It means it's byte addressable, which means your computer, your processor has the ability to say, I want to look at this particular byte in memory. I want to look at this particular byte in memory, and so on. But how can your processor differentiate one byte from another byte? How is memory organized, or all of these individual bytes organized in memory? How can we tell, oh, we want to access this byte but not that byte? Each one has its own address. Very good. Okay? So each byte in memory has its own address. Very good. But what does an address look like? Is it like an address that we deal with? Like, you know, like ARC is at 4700 College Oak Drive and stuff like that? Say that again? Okay, but how do we encode an address? Everything inside the computer has to be zeros and ones, right? And the same thing goes for addresses. An address is nothing more than a sequence of zeros and ones, and depending on which address we are talking about, that number is different. You were about to say something?
It's a binary code based on the bits of the system using.
Yep.
32-bit will be a 32 integer code, 64 and matching the dead code
With 64-bit wide. Exactly. That is exactly true. In other words, what he's saying is, if you're dealing with a 32-bit architecture, an address is a 32-bit number. Okay? So you have 32 binary digits, zeros and ones. If you have a 64-bit system, it is 64-bit wide. Okay? So it takes up twice as many bits to represent one address. Is that okay so far? Okay? 32 bits is how many digits do I need to represent 32 bits? Well, if we're dealing with base 2, that's an easy answer. Okay, we need 32 binary digits to represent 32 bits. Okay, because one bit is one binary digit. So that's a really kind of stupid question. What about in base 16? How many digits do you need to represent 32 bits? One hexadecimal digit, one base 16 digit, is representing how many binary digits? 2 to the power of what is 16? 4, okay? So one hexadecimal digit is basically representing 4 bits. So with hexadecimal digits, how many digits do we need to represent 32 bits? 32 divided by 4 is 8, okay? And how many digits are we seeing when we say print %x? Not counting the 0x, that's just the prefix part, okay? So we have exactly 8 digits. B, F, 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 F3, D4. Okay, well, that's a whole lot of mumbo jumbo, but what is the exact address in binary? Well, let's go ahead and let me just go ahead and convert this one for you, because I do want to make sure that you understand that everything is in binary eventually. So nothing is an exception to the rule, so this address is also in binary eventually, and it is, okay, B is 11, 11 is 1011 in binary, F is 1111, F is 1111, F is 1111, F is 1111, And then we have a 3, which is 0011. Then we have a D, which is 1101. And then we have a 4, which is 0100. That's the address. 32 bits.
You just have those letter to numbers memorized?
Yeah, because it's just a table lookup.
Okay.
So if you have used it enough, like one semester, you'll have it memorized too.
Alright.
You don't have to memorize it because most calculators can do base conversion for you. But if you do this for a living, a lot of times doing your mental conversion is faster than typing on the calculator.
Yeah.
So that's why I have all of these things. I can do it all in my head. But in this case, there's no calculation involved. It's really just a table lookup. Yep. All right. So you look at this bit pattern here. This is the address of our variable x. This uniquely identifies one location out of 4 billion bytes, and say x as a variable starts here. Is that okay so far? So the next question is, well, if that's the address, then how does an address relate to a variable? Why do we have variables if we can just use address? Well, do you want to use this to refer to a variable all the time in your program? No. It's the same thing with, yeah, go ahead.
When you said the address says x as a variable starts here, how do you know where it ends?
We know where it ends because we know how big x is.
Okay.
So I can show you exactly how we know how big x is or how many bytes x takes up, because you can also use size of to determine how many bytes x actually has.
Okay.
So in this case, x has exactly 4 bytes. The first byte starts at this location, then it will take the next 3 consecutive bytes as a part of x as well. Is that making any sense?
Yeah, are there ever any problems where it like reads into the next areas of memory into the variable?
Say that again?
Are there ever any problems where it like reads into the next area of memory into the variable for miscellaneous reasons? Or sorry, carry on.
Okay. Okay, I'll just kind of keep going in this direction first, and then if you have any questions, we'll deal with that later. All right, so this is really just this is the actual internal representation of the address of our variable x. The next question is, do you want to work with this number as the location and say, I want to store something at this location, or I want to retrieve the value at this location? Probably not, okay? Because this is a whole lot of stuff to type just to access a variable. Most of us prefer to use the symbolic name of a variable like XYZ, budget, expense, scanf result, okay, return value, stuff like that, because we can read the name of a variable and know what it is. When you look at a bit pattern like this, you probably cannot remember quite what is at this location, okay, because it doesn't tell you anything. So that's why we have variables. It is nothing more than an abstract concept or abstract construct that is created to make it easier for you guys to write your programs. But internal to the processor, this is how it sees the variables. It is just an address. Are we doing okay so far with the concept of an address as opposed to the concept of a variable? Let me give you another analogy. I have this stuff all typed up too, in the quiz, but I'm going to represent it here, which is okay. So we can go to maps.googles.com, and then we look up Arden Fair Mall, which I have not been to for years. I cannot think of any reason I want to go to Arden Fair Mall. Okay, so you can click on anything here. Okay, so let's click on Sears, and I can tell you what is the latitude and longitude of this location. It's that number, the number that I have just highlighted. Okay, so next time when someone tells you to go to a particular place to meet up, do you want a number like that, or would you prefer to say, oh, just Arden Fair Mall or a particular location in Arden Fair Mall? Which one do you prefer? The actual GPS number, or do you want to have the name of that location?
The name.
Most people would say name of the location. Very few people would say, oh, I want exactly the location, because if you have a GPS device, sometimes it's actually more handy to know the exact location. Okay, but that's the same thing. What I have highlighted here is the actual quote-unquote address. Okay, but what we know as odd and fair mall is a variable. It's the name of a variable, so it's easier for us to understand. Oh, where are we talking about? The odd and fair mall, not not just the location. Is that making any sense? The address of a variable is how the processor sees things, but how we see things as programmers is we like symbolic names. We don't like numbers just like that. Are there any questions at this point? No questions? Okay. If there are no questions, we'll go back to our GDB session, and we say, we can see what the address of X is. I wonder what is the address of Y, and also the address of Z. Okay. I think most of you would agree that they are kind of related, because if you look at the hexadecimal numbers, these three are different, but not by much. Okay. If you look at the address of X and the address of Y, it is only off by 4 bytes. If you look at the address of Y versus the address of Z, how many bytes are they off? This is trickier because you have to subtract C from 0. What is C? It's 12. Okay. Oh, but how do we subtract a 12 from a 0? Well, you have to borrow. But when you borrow 1 from the next digit, what is the next digit representing? How many 16s, right? So when you borrow a 16 to do this subtraction, you're essentially subtracting a 12 from a 16, which means it is 4 bytes. In other words, when you look at the addresses of X, Y, and Z, they are 4 bytes off from each other. Is that making any sense? Now that we know an integer takes up 4 bytes, and we have 3 variables declared, in consecutive manner, and their addresses are exactly 4 bytes off, is that making any sense to you? It seems to make sense, right? Because they are just variables, they're kind of clumped together, they're right next to each other. Is that okay? All right. So what can we do with an address in GDB? Okay, this is not done inside the C++ program, but in GDB, what can we possibly do with an address? We can take a look at an address, okay? Or we can take a look at what is at the address. Now, what is the difference between an address and what is at an address? There's a big difference. It's the difference between the GPS location of odd and fair mall and what is in odd and fair mall. Is that making any sense? Okay. So we'll go ahead and see what is at this location, and the command that we use is called X. X stands for examine. Now when you use the command X, you can specify a lot of things. Okay, you can specify how many things we are looking at. So in this case, we're going to look at 3 different things. Well, thing is very vague. So what exactly is a thing? Well, we can specify a thing is a W. W stands for word. One word, as far as GDB is concerned, is 32-bit wide. Okay, so we are looking at 3 things. Each thing is 32-bit wide. But when you're specifying, okay, we want to look at something that's 32-bit wide, you can also control how it is going to be represented. In other words, do you want to look at those as individual, as in hexadecimal, in base 2, in binary, or do you want to look at those as decimal numbers, signed or unsigned? You have your choice, okay? So what I'll do is I'm going to look at these things as, let's look at these in hexadecimal. So I'm going to specify X here. And then you can specify where am I looking at these things? What is the start location of these 3 things that we want to look at? So we'll go ahead and use BFFF3CC here, which is the lowest address of the 3 addresses. Okay, and I just type in the whole number. I did not type in %Z. I just type in the hexadecimal number, and then press the Enter key. It goes like, I don't really quite recognize these numbers, except for one. What currently has a value of 2? X has a value of 2. And what is the address of X? The address of X is ending with a D4. This is CC. CC plus 4 is D0, which is this particular byte here. This byte plus 4 is D4, which is this byte here. So is it making sense, kind of, at this point? No, not really.
So it's linking the other variables' addresses to get that byte.
Right, because it is the last one. This X turns out to have the highest address. The lowest address, the variable that has the lowest address turns out to be Z, which is a little bit counterintuitive in this class. But in CISP310, we'll see why it actually makes sense. But the most important part is they are right next to each other. Is that okay? All right, so if I single step, what is going to happen? If I single step, it's going to change Y. Y should become what? We know X is 2 already, so if I single step line 6, Y would become 3, right? Okay, so we single step, okay? And instead of looking at Y, I'm going to use X command again, okay? And do you see Y, where Y is supposed to be? Okay, the next statement will change Z to 8, okay? This is the statement that we'll single step next. And then we'll take a look at memory again. Do we see the 8? Are there any questions about this particular trace at this point, okay, using GDB? Yep.
What's the 0x? Like, is that just
0x is nothing more than a prefix to mean this is a hexadecimal or base 16 number. That's basically it. Yep, go ahead.
When you first did that for like the 3 items, the 3 things, and you were looking for Z, how did you know that the first, like, why did the hex value change on that?
You mean the addresses?
Yeah.
So you're talking about, you know, the address of X is this particular number, the address of Y is this number, and which is 4 bytes before the first one. The address of Z is this address, which is 4 bytes before the address of Y.
But when you, the very next line on GDB, typed in that, and then the very first number is B7DC000, why?
That's gibberish. It is uninitialized. This is basically the value of Z, but before we actually has a chance to initialize it.
Oh, okay.
So it's just a mumbo jumbo that is left behind by something else. And as a result, we can also see this is the uninitialized version of Y, but because by this time we already have assigned a value to X, that's why, you know, this location has a value of 2. Okay. Okay, so now that we have, you know, seen, you know, how memory is organized and how variables are stored in memory, let's do something that is kind of funky, okay? Let's go ahead and change the variables, but without referring to the variables. In other words, I'm going to use the GPS location to go to, you know, the Arden Fair Mall, okay? Instead of using the name, you know, of the place, I'm going to use the actual latitude and longitude to get to this location. So what I'll do is I'm going to use another command in GDB to alter the content of memory. Okay, so set var is set variable. This is how you can, you know, basically evaluate assignment operations. But instead of just saying, you know, oh, let's go ahead and change X to something else, okay, I'm going to do something else. What I do is I'm going to say something like this. F3cc equals to, I don't know, how do we want to change Z? Let's change it to 20 in decimal, okay? All right, so now we have this kind of weird expression here, but I can tell you exactly what it means, okay? Let's start with this part here, because we have seen it before. What exactly is that number? When did we see this number the first time? It's still, I think it's still in here. The first, yeah, the address of Z, okay? So the address of Z as a variable turns out to be this particular number. I know it looks weird because we're used to 0 to 9 as a number, but because this is base 16, it can also use A, B, C, D, E, F as digits. Okay, but nonetheless, it is nothing more than a way to specify 32 bits. Okay. Okay, so now that we know that part is the address, let's take a look at the other parts. This part here is called typecasting. In other words, when you look at BFFF F3CC, it is nothing more than just an integer value. It is really just a 32-bit pattern intended for calculations. Okay, you can do subtraction, you can do addition, you can do some multiplication, division, and stuff like that. Stuff that you normally do with integer values. But it is not seen as an address. So this is a typecasting operator to basically say, oh, whatever is to my right-hand side, which is 0xFBFFF3cc, treat it as an address to an integer. That's what this operator is. It's called typecasting. It is changing the type of something. Now, this is something that you would not have seen before in CISP300 because C, C++, and C are kind of the only few languages, one of the few languages with the concept of typecasting, which is saying, oh, you know what? Normally you would see what is following as a number. I don't want you to see that as a number anymore. I want you to see that as an address. Now, I can give you an analogy. The analogy is basically looking at this pair of numbers, okay? So when you look at this pair of numbers, 38.62602471 and negative 121.6343164447, okay? When you look at these two numbers, they can represent anything, okay? So most people look at these two numbers and go like, okay, you have two numbers. I don't want you to look at these as two individually independent numbers. I want you to look at this as a location. That's basically what it is. Okay, that's typecasting. It's telling you how to use the number. So in our debug session here, okay, the portion that I had highlighted before, this is basically just telling the GDB in this case how to make use of this particular number. Use it as an address. Okay, so now that we have explained this part, what is that extra asterisk doing here? This is the reverse of the ampersand. The ampersand operator is known as the address of operator. You give it something that has an address, it will find out what's the address. It's kind of like looking up, okay, you look up Arden Fairball in Google Maps, and we located the actual GPS location. This is doing the reverse. It's called dereferencing. In other words, you give Google Maps the exact location of something, and you're asking what is at this location. Is that okay? It's taking the address, it's using the address and take you over there. That's dereferencing. Okay? So, together, this entire part is saying, I'm specifying the memory location at that particular address. I'm taking you to the Arden Fair Mall. Is that okay? Sort of? Sort of? Okay. So let me just re-explain one more time. This is the GPS location. This is saying, oh, interpret the following as a GPS location because otherwise it is nothing more than just an integer. Well, if this is an address, what can we possibly do to an address in C and C++? Well, we can go to that location and change it. That is basically saying drive to that location. Yep.
The typecast thing there is the asterisk there just to indicate this is a pointer towards integer.
That's correct. Because you read it backwards, so the asterisk is int asterisk should be read backwards. To basically, this is a pointer or an address of an integer.
So with typecasting pointer, you have to make sure it's indicated as a pointer.
Correct. because otherwise you cannot dereference it. All right. So what do we want to change that location to? Well, this is the right-hand side of the assignment operation. So this means we want to change that location to 20. Okay, we'll go ahead and press the Enter key. Nothing seemed to happen. Okay, there's no output whatsoever with set var, but we should have changed something, right? Which variable do you think is changed in this case? C. Yep. And can we check that? Can we cross-check that? What do we do to cross-check that it is in fact a variable z that is now updated to a value of 20? Just print z, exactly. Just say, what is at Autumn Fair Mall? Print z, sure enough, it is 20. Okay, so this seems like a really big detour that didn't do a single thing, but it is actually an exercise to tell you guys what is an address and how do we make use of an address. Now at this point, we don't really use address for much other than just understanding what it is as a concept, and also we just understand that scanf requires an address. Yep, go ahead.
So, but if we make use of an address in a program, and then you have like the same address that's used, and then you have multiple processes of the program, so it's potentially using the same spot in value.
Aha, okay, that's a very good observation. So the observation is, when you run multiple versions of this program in multiple GDBs, they all seem to have the same addresses. But when you set one, it doesn't affect the other sessions. Okay, let me show you what I mean by that, okay? Because it's a good observation, and I do want you guys to kind of not have questions about that observation. So what I'll do is I'm going to open up a new terminal here, open up another GDB to debug exactly the same program. And list the program, we'll put a breakpoint on line 8, run the program, now we're on line 8. So right now what we have are two processes running in parallel. The first one is here, the second one is here. But when I print z of the second one, it is still 8 because I have not done anything to the memory locations. But when I look at the first one, it still has a value of 20. How is that possible? Maybe they have different addresses. Well, let's take a look. The address of z is BFFF-F3CC. The address of z is BFFF-F3CC. But how is that possible? Because they're the same location, but yet they have different values. Well, this is all thanks to a construct or a mechanism called virtual memory. Okay? Virtual memory allows the operating system to give your program, your process, the illusion that it owns everything. Okay? So it gives the illusion to a particular process and say, hey, you own 4 billion, or you have an address space of 4 billion bytes. This entire world is yours. So each process thinks, well, literally, that the world revolves around it. But it's virtual, okay? It's not actual, it's not real. And the underlying mechanism is fairly complex, okay? There's a translation process to translate addresses of each individual process into the actual physical location in RAM that you actually install in the computer. So I'm not going to talk about that process, okay? But that's a good observation. And at this point, all we have to understand is each process, each program in execution thinks that it owns the entire memory space. So when we talk about unique addresses, we're only talking about unique addresses within a process, but not across processes. Is that okay? But how do we know that there are two processes at this point? This is also a little bit beyond the scope of this class, but I do want to show you this command because it is really handy. PS is helping, it can list processes, okay? So this is kind of like listing files, except it's not files, but processes. -C means you want to filter processes based on their names. And right now we have two processes called main, or they are started by a command called main, and you can now quite clearly see that we have two processes. Processes are identified by numbers, just like everything else in the computer. So the first process is process 2436. That's the PID or process ID. And then the second process is 2567. And we can quite easily tell which one is which one, because 2436 is the one that has Z modified to 20. And then 2567 is the one that has not modified, and Z still has a value of 8. But to each process, it owns the entire 4 gigabytes of memory, even though not every location is accessible. Hold on a second here. How do we know that not every location is accessible? Well, because we can do something like this. So instead of looking, not this one over here. All right, so instead of saying, okay, let's go ahead and change the address of a known variable to 20, let's go ahead and pick some gibberish location, okay? All right, that sounds kind of gibberish, okay? And we say, we want to change that location to 22. Let's see what happens. Press the Enter key, and it says, cannot access memory at address blah, 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 blah. Because out of the 4 gigabytes of memory space, a very small chunk is actually accessible to a process. Oh, sorry, that's. Oh, is that mine or yours? Okay, because mine has the same ringtone. So that means your process actually only has a very small portion of memory that is actually accessible. What about the other space? Well, it doesn't map to anything. It's just void. It's just not. There's nothing there. So when you try to access a location that does not have anything mapped to it, this happens. It tells you that you cannot access that location. Are there any questions? You have a question?
But it thinks it can access all of it?
Well, this, how should I put it? It's kind of like, when you are looking at GPS, every place on Earth has a GPS location, which is basically saying every byte in this 4 gigabyte space has an address. But when you try to get to a certain location, you will find out that there's nothing there.
Oh, okay.
Yeah, nothing. When I say nothing, I mean really nothing. It's not just there's no building or no road. It really means there's absolutely nothing. That space does not exist, but yet it has a name. Yep.
So when you changed the value to 20 for Z, could you have also changed it to a character or a string?
No, it's just 20. It's just the value of 20.
Integer from the pointer to like character or string, would you been able to change the address?
You can do that if you want to. You can type when you typecast, you can cast it to a pointer to anything. So as a result, you can mess up stuff big time if you. Typecasting is basically you, the programmer, the developer, telling the compiler that you know what you're doing, and just tell the compiler, okay, you can treat this location as a location of blah blah blah. Okay, even though it doesn't seem to be that way, but you're convincing the compiler that you know what you're doing. So that's why typecasting can lead to really bad problems, because if a programmer makes a mistake, the compiler doesn't check. The compiler says, hey, if you tell me this is a location corresponding to an integer, I will treat it as such, even if it is not. Yep. That's a good question. Yep.
For a typecast, you typecast a variable, does it remain in the data type of whatever you cast it to indefinitely?
It only treats it as such when you are in the context of the typecast. Okay, let me tell you exactly what it means. Okay, so if you do a cast like this, okay, so if I turn this into a char, which means it is a character, okay, and then you can say that. Okay, so what this will do is it will treat the location at the address of BFFF3CC, only treat that one single byte location as a character. So I'm going to put the ASCII code of lowercase a into that location, and it will let me do it, which is not necessarily what you want to do.
Does it change the actual data type of the variable for the rest of the program, or?
There's no such. Okay, that's a very good question. So the question, let me just repeat that question because it really is a good question. The question is, if I do something like this, does it change the type at that location? Okay, the answer is really, really strange. There is no such thing as type to the location. Okay, let me give you an analogy, and that will end today's lecture. If I don't show you the map at all, and I just give you the coordinate, which is this part here, okay? Do you know it's a shopping mall? No. That's basically what it is. Typecasting is basically just saying, oh, treat it as the location of a shopping mall. Treat it as the location of a hospital. Treat it as the location of a restaurant, okay? So you are basically just saying, you know, at the time of the typecasting, treat it as such. But does it really change what is at that location? No. So if you treat this as the location of a hospital, what can you do with that location? You can send an ambulance over there, right? You can send patients over there. But does it really treat patients? No, not really, because it's not really a hospital. But you can cast it in programming and say it is a hospital. This is the location of a hospital. Treat it as such.
So basically just types are an abstraction that's just for the sake of the program. And
correct. Type is an abstraction that is only useful when we are programming. But when you look at the actual locations in memory, they're all just bytes. One byte has 8 bits, 8 binary digits, and that's all. Okay? Now, whether those 8 bits is a part of a 32-bit integer, whether those 8 bits is a character, whether those 8 bits is something else, memory itself does not know. Okay? It is up to the program how you use those locations that actually determines what to do with those locations. Okay? All right, so I think we got enough stuff for today, and today's lecture is recorded. I will upload it as soon as I get home, and you might want to review it. And also don't forget the homework assignment, which is in the form of a quiz this week, because I don't want to give you any actual pointer or address homework assignment before we get to the more important parts of it. All righty, that's it.